Assalamu alaikum class. Let's discuss the third solution in open addressing, that is double hashing. Double hashing works on a similar idea to linear and quadratic probing. Use a big table and hash values into it. Whenever a collision occurs, choose an other spot in table to put the value. The only difference here is that instead of choosing next opening, a second hash function is used to determine the location of the next spot. So while searching, deleting or inserting, first we will compute hash function and check that location. If it is empty, we will put record into it. If it is not empty, then we will calculate second hash function, that is hash 2 here, in which the formula is r minus x mod r, where r is the greatest prime number less than the table size. After computing second hash function, we will resolve collision by using this formula h of x plus I multiplied by h2 of x, where h of x is first hash function and h2 of x is second hash function and I is number of collision. Now let's solve an example using double hashing. For example, if user want to insert 12 in this hash table, first we will compute simple hash function. 12 mod 11 is equal to 1. 1 is already filled, so collision occur. Now we will resolve collision using second hash function. So the formula of second hash function is r minus x mod r, where r is greatest prime number less than table size. So table size is 11. So less than table size, the greatest prime number is 7. So 7 minus x's value 12, 12 mod 7 is equal to 2. So the answer of second hash function is 2 and the answer of first hash function is 1. So number of collision occur till now is 1. We will put the value of first hash function and second hash function in this formula, h of x plus I multiplied by h2 of x, and we will take again mod with table size if answer is greater than table size. So the value of first hash function is 1, number of collision occur till now is 1, h2 of x is 2. So the resultant answer will be 3. Now we will try to put 12 into the third index, that is already filled. Again collision occur. Total number of collision occur till now is 2. Again we will compute this formula, 1 plus 2 multiplied by 2. Notice that the value of first hash function and the value of second hash function will remain same. The only change is in I, number of collision. So the value is now 5. We will try to insert 12 at 5 index, that is already filled. Again collision occurred. So total number of collision occurred till now is 3. 1 plus 3 multiplied by 2 is equal to 7. We will try to insert 12 at 7 index, that is already filled. Again collision occurred. Now we will again compute this formula, 1 plus 4 multiplied by 2, that is equivalent to 9. Again collision. 1 plus 5 multiplied by 2 is equal to 0. Now we will try to insert 12 at 0 index. Again collision occur. Number of collision till now is 6. 1 plus 6 multiplied by 2 is equal to 2. We will try to insert 12 at second index. Again collision occurred. Number of collision till now is 7. 1 plus 7 multiplied by 2 is equal to 4. The 4 is an empty slot. We found a location. Now we will insert 12 at fourth index. Rehashing is the process of recalculating the hash function of already stored entries to move them to another bigger size hash table when the threshold is reached or crossed, and that threshold is 70%. When table gets too full, operations will take too long. So we do rehashing to distribute items across the hash table as to reduce the load factor and the complexity. As you may have noticed in previous example, when we were inserting values using quadratic probing and double hash function, total number of collision increases because table was too full. So the solution is to use rehashing. What we are going to do, we are going to build another table twice as big whenever we reach a threshold that is 70 percentage. In open addressing technique, it doesn't matter which method you are using to resolve collision, whether it is linear probing, quadratic probing, or double hash function. You need rehashing whenever you reach a threshold or you crossed a threshold that is 70 percentage. So how to find threshold value? First of all, count total number of values that are present in the table. In this table, total 8 elements are present. So 8 divided by table size 11 multiplied by 100, that is equivalent to 73. And 73 is greater than 70. So we need rehashing. Now we will build another table twice as big and prime. 11 multiplied by 2 is equal to 22. 22 is not a prime number. 22 plus 1 is equal to 23. Yes, it is a prime number. So the size of our new table is 23 from 0 to 22. Now we will rehash all the elements from the previous table to the new table by using the new table size. So first we will rehash 42. 42 mod 23 is 19. We will insert 42 at 19 index. Similarly, next element is 1. 1 mod 23 is 1. We will insert 1 at first index. Then 14. 14 mod 23 is 14. We will insert 14 at 14 index. Next element is 16. 16 mod 23 is equal to 16. Now we're going to insert 16 at 16 index. 28. 28 mod 23 is equal to 5. 28 will be inserted at fifth location. 7 mod 23 is 7. And then 31 mod 23 is 8. We're going to insert 31 at 8 index. 9 mod 23 is 9. We will insert 9 at 9 index. Now if we want to insert another value, that is 12, 12 mod 23 is 12. We're going to insert 12 at 12th index. As you may have noticed, now after rehashing, operations take constant time complexity of big of 1. Hash functions can be bad if you choose the wrong key, for example, age of the student, or if you use limited information to hash data, for example, first letter of last names. Hash functions should distribute keys evenly into the hash table.